What's going on, everyone? You're back with Jono for another quick math lesson. Today we're going to look at the volume of pyramids and cones. They actually have the exact same formula, so we can lump them together. The annoying thing about pyramids is that they don't have a uniform cross-section like we did with prisms. So remember, with prisms, if we just cut out one section, we know that it would just repeat over and over again. So all we had to do is find the area of the front and multiply by how far back it goes. But with pyramids and cones, this isn't going to work. But it's really obvious to think, oh, well, obviously the area of the base would matter, right? How big is the base of the object? And how high is it would also matter as well. So the area and the height are still the two most important variables when we work out this question. So the formula for a pyramid and a cone is a third of the area of the base multiplied by the height. We're not actually going to prove why this works in this lesson, but knowing that formula is incredibly important. So one way to kind of think about it conceptually is that if I had this exact same pyramid, but instead of it converging at one point, I just made a cube, just like this. What the formula is saying is that 3 of these pyramids would fit into this cube. And I guess that kind of makes sense. There are really good proofs on YouTube in other places, but this is all you have to kind of think. The area and the height still do matter, but it's got to be smaller than if this was just a normal cube. So when we're working out these questions, all we've got to do is identify the variables and then multiply it by a third. So this one would just be a third multiplied by the area of the base, which is 11 times 17, multiplied by the height, which is 10. Happy days. Throw that in your calculator and you get the answer of 623.33 meters cubed. And that's all you've got to do. So for this next one, we've got to find the volume of the cone, and it's the exact same principle. A third of the area of the base, which is the circle, multiplied by the height. So for this one, it would just be a third multiplied by pi times 8 squared multiplied by 10, because that's the height. If I throw that into my calculator, I get the answer of 670.21 centimeters cubed, and that's all I've got to do. This is way easier than finding the surface area for these shapes, right? The volume is much, much easier. The area of the 2D shape by the height. So for this last pyramid, we find ourselves in this annoying situation again, where the height and the slant length are different. So for this, we need the actual height or the altitude of the pyramid, not the slant length. So we need this green line here. Again, you can make a right angled triangle out of this kind of cross section just by connecting these lines. So if I wanted to find the height here, I could use Pythagoras. So because I've got the long side, I've got 8 squared is equal to the height squared plus 2 squared. In order to get h by itself, I just have to do some Pythagoras' theorem, but h squared is equal to 8 squared minus 2 squared, which if I throw into my calculator is equal to the square root of 60. For this, I do not want you to simplify the answer here. You can just leave it in your calculator as root 60. This is the most accurate number you could get. And so now I've got the height. All I have to do is do a third multiplied by the bases, which is 4 times 6, multiplied by that height, which is root 60. If you throw that in your calculator, you get the answer of 61.97 centimeters cubed, and you're done. So these volume questions are pretty cruisy. Just remembering it's almost the exact same as the prisms, but you've got to multiply by a third first. I do hope you found this lesson helpful, and I'll see you later.